The video today is all about telling if lines are parallel or not. So all of these postulates and theorems that we're about to learn are all ways to tell if two lines are parallel or not. Let's say we had this diagram here where line L and M are crossed by the transversal T. There are quite a few ways to see whether L and M are parallel. The first way is if you know that the corresponding angles are congruent. So let's say you had this angle congruent to this angle. Those are corresponding angles congruent, therefore L would be parallel to M. Similarly, if you know alternate exterior angles are congruent, for example this angle and this angle, let's say you knew those two were congruent, you could conclude that L is parallel to M. The next one says if consecutive interior angles are supplementary, so let's say this angle was 60 and this angle was 120, then you would be able to conclude that L is parallel to M. Similarly, if you know alternate interior angles are congruent, for example, if you knew this angle and this angle are congruent, you could conclude L is parallel to M. Whoops, I lost my M. Alright, finally, if you know that two lines are cut by a transversal, so they're both perpendicular to the transversal, such as if L and T were perpendicular and also M and T were perpendicular, you could conclude that L and M must be parallel. Alright, let's use these to figure out what lines are parallel. This first one says angle 1 is congruent to angle 6, so let's mark that in our diagram. And I also want to highlight over the lines that create those angles. So P is the transversal, N and L are the other two lines that I'm looking at. So these two angles, 1 and 6, if you want, you can ignore totally all the other pieces of this diagram. So you can ignore this line, line M, because it's not doing anything. It's not one of the highlighted lines, so we can totally ignore it. Now, looking just at what we have highlighted, angle 1 and 6 you can tell are alternate exterior angles. Since they're congruent, I know L must be parallel to N by alternate exterior angles converse. Similarly, on part B it says angle 2 is congruent to angle 3, so I'll mark those congruent first, and then I'll highlight the transversal and the lines that create those angles. So everything down below here is not anything that we're concerned with. We really only care about line L and line M. Since angle 2 and 3 are alternate interior angles and they're congruent, I can conclude that line L must be parallel to line M by alternate interior angles theorem. Make sure every time that you're trying to prove lines are parallel, it's always the converse of the theorem. Remember, the regular theorem starts with the lines parallel as the hypothesis and concludes that certain angles are either congruent or supplementary. However, on all the converse statements, it starts with the fact that the angles are congruent or supplementary, and it's concluding that the lines are parallel. Let's do another one. It says, find the measure of angle MRQ so that A is parallel to B. So if we want A to be parallel to B, we would know that the alternate interior angles, these two that we have the measures for, must be congruent. So I'll set their measures congruent. 5x plus 7 equal to 7x minus 21. If the angles are congruent, it means their measures are equal. Now to solve this, I can start by subtracting 5x on both sides and add 21 on both sides. Next, divide by 2 on both sides, and we get x is 14. However, the problem asks us to find the measure of angle MRQ. So I need to go back and plug in the value of x for the expression given for angle MRQ. I could check this answer by plugging in 14 for the other angle, RPN, and make sure it also is equal to 77. Next, let's look at using these postulates and theorems in actual proofs. You can use any of those theorems that we just learned above in Goal 9 in a proof. So for example, if it is a proof like this. First off, it didn't label anything in the picture, so I went ahead and added points so that I'm able to talk about these angles. I know that I'm trying to prove CB is parallel to DE. I notice that 130 and 50 are supplementary angles. So that's helpful because I have a plan now, because I see that angle CBE would also have to be 50. So I'm going to have to show that angle CBE is 50 since 130 and 50 make a linear pair. Okay, so you should have the given written down. Next, I was planning on showing that angle ABC and CBE form a linear pair. So I know the measure of angle ABC plus the measure of angle CBE has to equal 180 by linear pair theorem. I'm trying to show that angle CBE is also 50 degrees. So let's plug in 130 for the measure of angle ABC. That's called substitution. Now, in order to get the measure of angle CBE alone, you'll have to subtract 130 on both sides. I'm going to go ahead and do this in one step. Remember, you are not allowed to abbreviate substitution or subtraction. But I'm going to subtract it and simplify it all in one step. Okay, now that I know the measure of angle CBE is 50, let's label it in the picture. I know that angles CBE and DEF have the same measure. I can get that by knowing that DEF is equal to 50, so I could plug in DEF for 50. That's called substitution. Now, in order to use one of the theorems from above, it says that the angles have to be congruent. So I'm going to say angle CBE is congruent to angle DEF by the definition of congruent angles. And finally, now that I know that those two angles are congruent, I can conclude that CB and DE must be parallel. Can you tell me what theorem I need to use? Finally, reflect on this question, please. I need you to summarize the 5 methods used to prove that two lines are parallel in a few sentences. Thanks.